I think that brings us now to the question and answer session, and we've got about an hour now where we can really roam across the whole of the CobBauge project and gather in all the questions from our audience. So if we can bring up the panel, Francois Streff from Normandy, Jim and Matt from Plymouth, Becky from Scotland, Barry from Devon, Anthony from Norfolk. I think that will be, and Roland, of course, from London. That will be our full complement. I wonder, to start off, it didn't come out, I don't think, in any of those site tours, but one of the original aspirations of the CobBauge project was to reduce the amount of waste in the construction process by using soils from site that would otherwise have been waste from excavations. And I know through the scientific research we did that it became apparent that the qualities of the clay you needed for the slip, for the thermal layer, and for the structural layer were rather different. But I wonder, in the 3 sites that we have under construction, how the earth was sourced for those 2 kind of mixes. Anthony, you're on my screen, so maybe I'll come to you first, and then Francois, and down to Plymouth.
Well, we've got a fantastic stream of clay which runs actually all the way from top northeast of Norfolk all the way almost down to Devon, doesn't quite hit Devon, and that is an incredibly rich bit of clay. That's the 65%. That's the clay that came from King's Lynn, which is literally 10 miles away from Fakenham. Somebody asked, where is Fakenham? It's on the North Norfolk coast. It's just north of Norwich, just south of King's Lynn, and so we've got this King's Lynn clay, which is a grey clay, which is 65%, and is absolutely perfect for clay. So no waste there, no addition other than putting your shib in. And then we've got to the southwest, we've got in Durham, we've got another streak of clay which is perfect for the cob. And as I showed on that kind of that particle graph, it's just on the edge of being absolutely right without any additives. So we just needed to add a little bit of aggregate to it. So and in terms of waste, there will be absolutely zero waste, absolutely no waste at all. And in fact, on our open day, we had a representative from the clay pit, and he was delighted to see us using this cob, because he says he's got no use for it whatsoever, and a lot of waste is they just have to bury it and then they put topsoil over it. So he was really, really excited to see something happening to it.
Yeah, that's fantastic. Of course, another thing we're trying to do is reduce the amount of use of primary materials like sands and gravels, which are a limited resource in themselves. Francois, how did you get on in France in terms of sourcing your soils?
Well, when it comes to the Normandy prototype, we mainly worked from the resources that were available in quarries, and this was because we wanted to have a material resource that was enough to meet different projects. So we created an inventory of the sand quarries that often generate a lot of soil that they don't use. So clay, for example, that comes from the washing of the sand in different sand quarries. So we mainly sourced our soil in that way, both for the soil used for cob and the very clay-rich soils used for the light earth. Both came from quarries. But this doesn't mean that we can't also use local earths and soils. We're lucky enough to have very interesting geological soils in Normandy. I think it's the same case in Brittany. I saw some people put in some comments in the chat around the clay-rich soils available in the west of Brittany. So we've got soils available in the northwest that are perfectly suited to building with a load-bearing cob or insulating light earth.
Fantastic. I think it's, while the Interreg project is based between the north of France and the south of the UK, and the sites and the soils are all relating to that geography, I think the intention is that the technique is applicable, globally, although I see in the chat there was discussion about seismic zones, and I know the CobBauge team are working with colleagues in California in a seismic situation as well. But guys down in Plymouth, how did it work out for you in sourcing soils for the two different mixes down there?
So in an ideal world, we would have sourced the soil from the site on which we built the building. But Plymouth, being Plymouth, it was bombed very heavily by the German Luftwaffe during World War II. And many of the buildings around by where we are would turn to rubble. So when we started doing ground excavations, a lot of that rubble was found in the ground. So we needed to start looking for soils elsewhere. We were starting to look for soils from waste sites, from local developer sites, to see whether there was waste that ordinarily would have been paid for to be removed from site. So this waste material on other sites could have a value with CobBauge buildings. And we started looking for those types of soils. In the end, we settled on soils that came from Ottery St Mary and another site in Crediton. I don't know whether, Barry, you've got anything further to add on those two soils as a sort of, from a structural engineer's perspective.
Right. Well, obviously, if you've got existing cob buildings in the area, it's usually a pretty good sign that you've got the right type of soils for making cob. It's not always the case, but certainly in Crediton, a large proportion of the buildings in the area that are more than 100 years old are formed in cob. So it was a fairly good bet that the local soil would have been suitable. But having said that, the geology can change from one place to another, and the soil where I am, which is just 5 miles north of Crediton, is completely different, but also suitable for making cob.
And there was a lot of questions earlier, which in the day, which we're going to try and now bring forward to our panel. But if any of the audience have questions, please put them into the chat, and then we will put them to the panel. I wonder, Anthony and Francois, there was a discussion earlier about how we've designed for thermal performance, and whether, I guess, you could enhance the thermal leaf to achieve passive house standards or ACB build standards. And there's a question in that, I guess, both about the U value and about air tightness. Francois, I know you replied to that perhaps in French, but could you discuss that for the audience?
Yes, of course. I think the question was about the passive house standard. At present, the U values that we get, as I said this morning, these theoretical values are around 0.26, where the passive house standards are more restrictive and more demanding. There's also the question of air tightness of the building, which is a very central factor that comes into play for the passive house standard. So I'm just touched upon some of the questions, and I discussed the results that we got for the Normandy building. We had an air tightness, a final air tightness of 0.46 cubic meter per square meter per hour, and that's still very far from the requirements of this passive house standard. So it's quite likely that we won't be able to get this standard and meet this standard. What we hope is that we can get closer to the consumption that are close to that of a passive house. this kind of standard requires certain performance from the walls, both in insulation, so U value, and in terms of airtightness, but this forces you to have mechanical ventilation, a double flow ventilation, to meet some of the objectives. But what we were trying to do was to try and have a low-tech technology where in the end we could not need or limit the need for ventilation. And this means large savings. And we also wanted to have a thermal performance that was increased thanks to the moisture regulation properties of the soil and clay in particular. So this would allow us to have an indoor air quality and an indoor comfort through this moisture regulation that allows us to not need to heat as much, and this means that the global consumption is more interesting than a simple theoretical regulatory calculation that is asked of us in these standards. This means that we can get closer to the same consumptions as you would see in passive house. I think it's 15 kilowatts per hour per year. We've also got a question from Eric Arsenault, who's asking us if we could touch upon price. Maybe to answer this question, we could give a price range for each building per square meter, or something different, just to give them an idea. Francois, maybe?
Maybe also how the cost divided between the material, the mixing processes, the issues of formwork and scaffolding, and what was discovered through the pilot buildings.
Sorry, I wanted to jump in on that previous question because I think there's a very important point to be made here, that we shouldn't see ourselves as aspiring to become something like passive house. The whole point of this building, I think, is to provide an alternative to the passive house approach to high-tech mechanized building. We should be able to display, as Francois said, that these materials can provide a better indoor environment than a passive house necessarily can, at a fraction of the cost and a fraction of the embodied energy. I think that's the point, that we are not chasing passive house, we are a different approach.
Can I say something about that as well? I mean, I think passive house isn't really, I mean, that doesn't necessarily have to be high tech either, passive house, because it's just a requirement for heating and overheating. And I think and it's also about form factors and glazing and all the rest of it. So it's quite complicated, passive house. But what I do think is that we do know anecdotally that COB buildings behave significantly better than it would seem to be from U values. And we had a lot of discussion at our open day yesterday about how could we improve the thermal conductivity of a wall by increasing maybe the thermal thickness of the lightweight and reducing the structural thickness, because obviously building regulations for the UK are getting more and more onerous, which is absolutely right. But by 2025 it's got to be 0.15 U value, which is going to be difficult for everybody to sort out. But I think we've got to recognise all the other, as you said, Jim, all the other amazing benefits. Their way of buffering moisture, their VOC, the way they deal with VOCs, the way there's kind of acoustics, etc., etc. So there's, as you say, there are lots and lots of benefits which we need to be shouting about.
I think, it's worth saying we're showing a standard wall design with an equal thickness of structural and thermal, but of course it's possible to vary them, to build a taller building with a bigger structural leaf, or a more insulated building with a thicker insulated leaf. Francois, in your presentation, you mentioned that one of the things you wanted to test in your building was the difference between theoretical performance or design performance and the actual performance of a building in use. And, there can be some variation between, for example, U values and a building in real life. Can you, and somebody was asking this in the chat, can you predict what you think the real performance of your building will be from the data you have so far? And then maybe go on into this question of cost.
Well, it's a bit of a tricky question. I'm not. I have to admit, I've not done specific calculations around theoretical consumptions of this building, which has a very particular use. It's a small building, 13 square meters and living space, and it won't be used regularly. So we designed it as an experimental object, really, for universities, for academics, for scientists, and this will allow us to evaluate the difference between theoretical calculations and real-life consumptions. How we do this is the way that we can play around with the building, which is equipped with an electric heater, electric meters, so that we can monitor the real consumption of the equipment. And so this means we can increase the temperature in the building at certain periods, or we can play around with the moisture content that the building has to deal with indoors to just measure the impact in terms of heat transfer, for example. So it'll be difficult using the Normandy prototype to get a realistic idea. It's at the cross of data and building data of Plymouth and Twickenham that will probably allow us to have a more realist vision of the consumption of this type of building.
And then the issue of cost, because I know Raphael did quite a lot of detailed monitoring of how many hours to work in which technique and how much the relative cost of materials as against the different elements of the construction process.
Again, here I'm going to have to remain quite vague and dodge the question in the sense that the Normandy building is the first one that was built using the technique, so we had to go through a lot of learning phases, and especially on the building process. So we implemented everything on a full scale using that project. So we tried out variant methods, different uses of different tools with the workers that helped us out on the site. So the cost for me is not representative, but the work that Raphael did allowed us to measure the difference between the laying time between each lift. So we realized that between the first lift, where builders were discovering the technique, the process, and the fourth lift of the ground floor, so the last floor potentially of a ground floor, we'd divided the implementation time by 2, simply because we'd improved our use of the different tools. The contractors were organized, so we managed to move from 1 square meter of wall built in 12 hours to a division by 2, so 1 square meter in 6 hours. And we also did this monitoring when we started building the upper wall. So there was a bit more handling of the earth, especially because we were using scaffolding because we were higher up. And so part of this work was done manually, and obviously here we moved back up to 8 hours per square meter of wall. So this just gives us a basis for evaluation of building costs. But here again, the Normandy building is not very representative, because this small 13 square meter building, on which we tried out many techniques and therefore encountered many different little problems, can't give us a realistic vision of implementation time for a normal building. So it's quite likely that everything that we will learn from the building that Anthony is building in Twickenham will be much more useful in terms of evaluating real costs for building for this type of technique.
Okay, thanks, Francois. Roland, I wonder...
Yes, I just wanted to come in again here and say that the time data that Francois was giving are 6 hours per square meter per man. So it's man hours. So if you've got 2 workers, you divide that time by 2.
Okay, I think that you referred to Francois' earlier presentation there, Raphael. Roland, I wonder, I mean, one of the aims of the project was to look at taking something from, you know, CobBauge from a craft tradition and bringing it to offer the benefits of low carbon construction for mass house building, and, you know, looking at simplifying the processes and the degree of skill and knowledge and controlling quality through the use of formwork and standardized details and so on. And, you know, we've experimented with that in different ways across the sites, 2 of which used contractors who were experienced in earth building, and the Twickenham one, which wasn't, where people were trained up. I mean, from your broader perspective of building with earth and formwork and so on, do you have a view about where the cost lies between materials and processes and the scalability of these sorts of projects?
Yeah, I mean, what's clear is that the materials is the lowest cost. You know, you're not, there isn't a lot of money in the energy around these materials, and so that's something that's going to stay fairly static over time. So then you've got formwork, and we've seen that there's different ways of putting that formwork together, and so it might be something that in time becomes something that you can rent, as you can rent concrete formwork, or it may be that it remains something that contractors put together themselves, and how they control their costs and what they're doing. We saw yesterday in Norfolk that the size of timbers in formwork is something that I suspect is going to get smaller and smaller, lighter and lighter, less and less cost. And so what you end up really then is about people and skills in managing plant, scaffolding, access, all these kinds of things. And immediately in Norfolk, there are changes happening, and the guys on site are saying, what we really need here is 2 teams working side by side up 2 ends of the buildings, not 1 team going around the whole thing, so that you've doubled the labor on the site, but then you've halved the amount of time that it's there. All this kind of fine tuning is something that, you know, we should have more experience of now, but we're a little bit a victim of COVID. But you know, I think that all of this stuff will change all the time. Again, in Norfolk, we saw that the placing tool, they've already adapted and changed to look similar but quite different to what was used in France and Plymouth. So everything is changing and evolving, and different users will find their own way to this. But essentially, the materials are low cost. So it's really then just about how builders, designers manage the rest of the process.
Thank you. Does anybody else want to come in on that?
I can just add some specific figures from the Plymouth build. I'm perhaps not going to give you the actual exact costs, because I'm not sure if that'd be useful at this point, but I can say that the labor cost was almost exactly twice the materials cost, which is not the case for conventional construction. So as Roland said, the materials themselves are cheap, the labor is higher. And we did for our building, which, if you remember, is a relatively small building, so the costs per square meter are going to be higher, but the cost per square meter of wall, to answer the original question, was £614 per square metre, including labour and materials.
And so that's a relatively high cost, although when we, from experience, one knows that the cost of the light fittings will also be quite high, right? All those other costs will bring the relative cost of the wall right down. There's always this sort of idea that it's the walls that are expensive bit in a building, but they're not really. So I think that 600 is high. I think it will definitely come down from that. You've got a contractor who has never used cob and a cob builder who's never used formwork working together with us to achieve an outcome. Doing it the second time round, they'll both be better informed. So there is definitely an experience thing here.
And also,
there is very much a confidence thing, as we noticed again on site in Norfolk and Fakenham. It's taken us. We've had 2 sessions with Paul and Sol Barkley, who did the Plymouth build. And it's just they've had to come back and sort of really hold hands with the people in Norfolk. Norfolk has no cob tradition. It has adobe tradition. It has lump earth clay tradition, which is very, very different. But it's seeing that confidence build, and therefore the kind of smoothness of operation kind of improve is going to be great. So to start with, has taken a long time to do our first few lifts, much longer than we'd anticipated, but already yesterday we started seeing them speed up. And we definitely, whereas Plymouth was built by a team of 2, I think, or 3, we absolutely need, and we have a progress meeting tomorrow, we need at least 8 on site to do this properly, and then we could have it up in 2 months easily, absolutely easily. But it's just kind of really realizing the difference in scale between Plymouth and Fakenham.
just kind of following on from those costs that Jim provided, that was an average over the duration of the construction process. And you're right, Roland, that the build process for the first lift was twice as long as the build process for the final lift. So the guys got much more confident, as you were saying, Anthony, but also wrapped up with those costs. Almost a third of the cost of that £614 was attributed to formwork. So if in the future we might be able to have formwork that could be replicated or reused over and over again, then the costs are going to come down, both in terms of labour costs and in terms of material equipment costs as well. So I think that 614 is high, but it's definitely got scope to be reduced.
And it was a prototype and a small building, both which will exaggerate that cost.
And built during COVID on a university site. So yes, a number of things that weren't entirely normal. Jim, measuring cost is one thing, which in this case wasn't a precise science, but the other thing we were hoping to measure was embodied carbon. Where are we in that process, and what are the variables that affect that?
I'm having a very interesting experience. I'm the lead on that part of this project, developing figures for that. And I've got a huge amount of data from our build. And the main problem is that when you do conventional life cycle assessment, you cannot add human labor as part of that process. So the actual embodied energy of the materials is negligible. So we will have a very good figure. So when we produced our environmental product declaration, which the EPD that we plan to do by the end of this project, it will show a remarkably low figure. But if you take into account the human energy that goes into it, it'd be very different. And I think we need to look at a way where life cycle takes into account those aspects as well. But the actual figure for the life cycle assessment is still a work in progress, I'm afraid.
Okay, I guess part of that, we can understand the earth and the fibres and so on have very low embodied carbon, but but there was a discussion within the program as well about finishes and the different kinds of finishes that we're showing on these different buildings. From your perspective as an experienced COB builder, what do you think the range of appropriate finishes are, and the pros and cons of the different ones we've experimented with?
Ooh. Well, I mean, the obvious thing is to look at tradition and look what works. And so lime hull is kind of the obvious way to go. And as I said, the hot lime hull being the most effective, I think. But these modern products are looking quite positive, but I think we've got to be a little bit careful what's in them. So really dig deep about what the materials are in the modern products. And then, of course, another idea is to use earth renders, which is something we have been using in Scotland. But with earth renders, no question about it, you need more maintenance. And that's something that has to be, in a way, it's a cultural change, though, because you can maintain an earth render a little and often, and it's very easy to do by yourself, maybe not need a contractor. So it's just a different way of living with your building. But I do think that should be considered for the right kind of building. I don't know whether I'm allowed to jump onto a different issue, but I saw a really interesting comment about prefab light earth blocks by Andy Horn in the questions coming in. And maybe just to mention that prefab was an issue that we were hoping to look at, but we didn't have time or resources in the end. But I would quite like to follow up on that comment in the chat about prefab light earth.
And just quickly to say that other forms of rain screen are available, so a timber rain screen, also would work perfectly well.
So we also did different studies on prefab, and at present this gave us encouraging results, rather positive results, and this allowed us to create blocks that were about 2 meters long and 70 centimeters high and wide. So we managed to move these quite easily. So it's an avenue that we've planned to explore further in the future, especially to solve this problem with drying, which is one of the main constraints of this technique. The advantage of the technique, even though it shows little evolution on the economic front between a traditional cob wall that would then be insulated and our CobBauge technique, the price is fairly similar. But the main difference is that with the technique that we've developed, the insulating element is implemented at the same time as the load-bearing element. And so you gain time on the site works, because you don't need to wait for the cob to fully dry before you add an insulating element. So you implement both at the same time, and that's the point. That's where the costs are reduced compared to traditional cob. Around this question of gains, I just wanted to touch upon that, around the exchanges that we've had with tradespeople that we worked with. It also turns about the tiredness of the work. So it might not be as true for sites in the UK, because a lot of the cob and light earth had to be implemented manually because of accessibility site constraints. But if you can use machines for many things, for example, the implementation of formwork can be done quite easily with machines. We worked with panels that were over 6 meters long, and we could lift all of them in one go using machines on site. We had tie systems. We used some concrete formwork, and this meant that we could implement the formwork quite easily and quickly. And when it comes to laying the materials, it was less strenuous on, for example, our workers' backs on site. So we have a really good example. One of our builders is over 55 years old, and he's he's very attuned to these different elements, and told us that this technique was interesting for him as a tradesman because this could limit how strenuous. We've got a question about, I'm just going to read it out, I think. So it's something about thermal regulations. What about the other constraints that allow you to have a 10-year guarantee? So the link between that and insurances. How can you answer this question around the 10-year guarantee? So when it comes to this garantie décennale, the 10-year guarantee, which is, I guess, a very French issue, but I'm sure there's equivalents for responsibility in England and insurability in England. At present, the earth buildings are not necessarily covered by 10-year guarantees, in the sense that there is no professional set of rules and there's no DTU, so standards that cover earth building techniques. So the only documents that at present cover earth building are good practice guides, and these aren't really recognized by insurers. So every time we find ourselves in a context of negotiations between companies and their insurers to guarantee over 10 years the works that are carried out by contractors. It's the same thing for architects who have to also negotiate. So it's relatively easy to get a 10-year guarantee for buildings that are done in the private sector, but once you start working in public buildings, then it's much more demanding, much more complicated, and at present we have no other choice but to go through experimental technical assessments, and then we can ensure the technique.
It's interesting that on the other side of the channel, how we've managed to construct what might have seemed quite challenging things for an innovative building, a speculative house development and a public building for a university client. Can we maybe shed a bit of light on the system there in terms of that, introducing innovation into construction and the challenges around insurances and indemnity and so on? Anthony first, maybe?
Well, we're still, as I think I mentioned, we have the builder who's building the house in North Norfolk, Fakenham, it doesn't know whether they're going to rent it or whether they'll sell it on, but they want they do want a mortgage. But I can't give you a precise answer at the moment because we're just going through the whole thing with the insurers and their building society about whether it's acceptable for us to give an architect certificate and what requirements they have. I think if we did it through the NHBC, that's the National Housing Building Council, I don't think we would get insurance from them at all. I think there are too many technical issues which we haven't solved or will be able to convince them about. However, through our professional indemnity insurance, I think there's a little bit more of an opening, but obviously it's a much bigger, it's a risk for our professional indemnity insurers to take that on. So we can't give you a categoric answer at the moment, but we are going through that process. And that 10-year guarantee, our collateral warranty, we usually only do for 6 years. We don't like to extend it to 10 years, but I've got a horrible feeling that we may be asked to do it for 10 years on this.
And Jim and Matthew down in Plymouth, how did you get around questions of, well, I guess both for building standards, but also from the university as a client with insurances and so on?
In terms of building standards, so we work very closely with building control. So we brought them along to open days, to some of our training events really early on at the university when we were building the trial walls in the laboratory. So they kind of understood the process and what we were trying to do. They were very supportive of our project, and there were very few, if any, problems going through building control. With regards to insurances, like Anthony, I got in touch with my professional indemnity insurers and explained the process of using CobBauge and how it was an innovative earth building construction. They were perfectly happy to cover me because it was within my professional indemnity insurance limit. So that was okay. With regards to building insurance, unfortunately, I don't have information on that. It's all been dealt with through the University of Plymouth Estates Department, and it's a much higher level kind of discussions than I was privy to, unfortunately. So I couldn't comment, but I think as far as I'm concerned, or as far as I'm aware, it's all covered underneath the universities and general building insurance.
Brian Speckman in the comments has said, speak to BLP Building Life Plans, who insurance and open-minded about methods of construction. I think that there are sort of more like private warranties out there available, and we probably need to start building relationships with them.
I mean, it's interesting. We had a issue about fire, and I mean the project, and we were asked whether we could show, fire test the buildings. But then when we looked into it to get a BRE report or something, it's like £30,000 or £50,000 to do it, and also doing rain tests in laboratory rain tests. I think about 6,000 on one sample. So you start needing a lot more investment to be able to get to that to that point.
Yeah, there's a comment in the chat there about the DTU, and just remind me, Raphael and Francois, where we stand with the DTU.
So yeah, I was just answering that in French, but by message. As far as I know, there is no DTU for straw. So DTUs are unified technical documents that frame the different building, industrial building techniques, mainly. And so there is no DTU for earth. And I cannot really see how there could be, in the sense that, as we've already mentioned, each soil is different. We're not on a standardizable product, except if then we start using an industrial product, but that is not what we're aiming to do here. Here we're trying to value the local resources that are available, so it's not something we would want to do. So around this question of regulations, at present, straw is covered by good practice guides again, and these are recognized by insurers who have expressed positive opinions on the use of this material, just as they have with the use of hemp or earth renders, of different renders on raw earth. So these are covered by certain rules that are produced by professionals and are then validated by insurers. We have an initial few steps taken around regulations for earth construction in France, around traditional techniques. So this has led to the creation of this good practice guide. And these are the initial stages of professional rules, but they have not been validated by insurers yet. So this good practice guide is an initial standardizing guide for practices in France, and this allowed us to assemble all the different professionals in the earth building field, and they created this document. But we're still very far from a standard document like a set of professional rules. So for now, earth construction techniques, traditional ones like CobBauge, for example, are not yet covered. And therefore, every time we find ourselves in this kind of question of relationship between companies and insurers and whether or not they insure them. In itself, the CobBauge technique is just an association of two techniques, one that is quite traditional, Cob, and one that's slightly less traditional, a bit more recent, as Roland was saying earlier this morning. The installation technique using light earth, but both these techniques are already described in good practice guides. So insurers who accept to insure traditional techniques could then refer to the existing good practice guides and then insure CobBauge techniques.
Harry, I wonder, what Francois says here is that, this isn't a certified product, but CobBauge is a kind of a technique with guidance that's really not that innovative. It's, it's light earth construction, which has been around for quite a long time, and it's COB, which has been around for millennia, but it is a naturally variable material. And in terms of these issues of, professional indemnity insurance and engineering design, does that mean that you really just approach it with the same certainty as you would for a normal COB building? From an engineer's point of view, are there any challenges around certification and warranty, or do you approach it with the normal engineering approach? I've
not come across it before in this country with the various COB buildings that we've done in the past. The building regulations are quite accommodating from that point of view. It's got a nice little paragraph in it which basically says if it's a traditional material that's been used before, you can use it for building new buildings. So that's very useful from our point of view. In terms of insurance, buildings insurance rather than warranties, there again, there's a huge stock of existing earth buildings which are continually changing hands, and people are getting buildings insurance on them. They may find that the premium's a little bit higher, but apart from that, yes, that's not a problem. I can't think of an instance where someone's tried to get a sort of building warranty insurance on a COB building, though. Certainly there are buildings that I've done where I've provided a sort of designer's certificate to go with it, not necessarily for lenders, just for the owner's use. But certainly you could provide one. There again, it's no real different to any other building.
So we've got one last comment that says that Earth has proven its positive points, and here we need to really reassure insurers to be able to have more of these Earth projects. There's a question maybe around the relationship between the insurer and other parties. I had maybe a question. Would it be possible to develop professional rules specifically for CobBauge without having to resort to this lengthy work? With not having to work at the entire earth building sector level and developing general rules. I don't know if this would be possible in England, but in France, would we be able to develop something similar to an ATEX for CobBauge? Could we develop a specific professional rule for CobBauge? Well, in the future, maybe, but I think it's quite premature at this stage in the sense that a professional rule is built by professionals who use the technique and have enough examples to base their experience on. So here we're on a slightly different technique different from traditional techniques. Having a specific professional rule for CobBauge is probably premature, at least for French players. Maybe in a couple years, when we have enough examples, enough companies who have used the technique, then we can start developing this type of document like we did for the hemp sector or the wheat sector. But we had to wait for several professionals to be trained and to start using this technique and have on-site works that exist to move from a good practice guide to this set of professional rules. So it could be an objective, an aim, but this is something we can only reach in a couple of years when we have a sufficient amount of examples. So at the moment in France, I don't think that we have any other choice but direct negotiation for private markets between companies, architects, and insurers. And when it comes to public buildings, we have to go beyond and use the experimental technical assessment process. We've also got another question that kind of moves away from administration and comes back on the more tangible aspects. It was a question that was asked a bit earlier. Do you have a minimum horizontal distance that you would recommend between two openings? So could we give dimensions for openings, for spacing between openings, distance between openings and corners? So is it similar to COB? Or are there specific rules for CobBauge? Well, I think they're fairly similar to COB. It depends on the engineer's calculation, so I think I'll let Barry answer further.
I was going to say that really depends upon the building, and you have to look at each one individually. Certainly with the buildings we've been doing so far, they've only been single-story buildings to start with, so the loads per meter run is relatively small, and it's mostly been roof load. So, but it's once you get up to a two or even three-story building, you're going to have to be more careful about how you concentrate loads from the sections of wall above.
Can I just ask a question about, go back to Raphael on the previous question, whether he's using the word professional in a kind of French sense where it seems to be more about site and workers, or in a UK sense where professionals we think of as architects and engineers?
Well, I think professional is just the term that we used for all players in the building sector. So builders, architects, engineers, everyone really, economists. So professionals is the group of different players in the sector.
Okay, because we've done quite a lot of work on training, learning outcomes for people who are more on site. The bit that we haven't addressed as systematically is for the designers. It's something which we are working on at a European level with a number of different organizations. We have written learning outcomes for site and designers for CobBauge, but at the moment they're still in draft because they have to be put in front of the European network of organizations for agreement. So at one level I take Francois's point that this is something for the future, and on the other I'd say that we have sort of begun to address some of this stuff over the past 10 years, and then again particularly through the CobBauge project. So yeah, it's just a slightly different perspective.
Great. Okay, we have a fantastic question in from Eva, who says, having experienced female-led natural building projects around the world, I'm wondering what we risk losing when female and indigenous knowledge can only be legitimized in capitalist society when it enters the androcentric scientific sphere. This makes me wonder who will ultimately benefit from standardizing natural building materials. I hope I'm not going too fast for the translators here. Will we look back in decades to come and wonder how we allowed female and indigenous knowledge to be monetized in this way? And I think there was a question this morning about this issue about capitalism and the patriarchy in our contemporary building culture. And it's a great question. I'm wondering who wants to stand up and respond to this first. Becky, this is maybe your area of expertise, and then Roland, I see your hands up. But you just spoke, so I shall ask Becky to come in this one in the first instance.
Thanks for asking that question. It's a good one. Well, as somebody that straddles those worlds, obviously I'm a female in a building industry. I work largely with women and communities, but I also monetize my work in a capitalist society. And yes, I think ultimately to save the planet, we do need to turn over capitalism and the patriarchy and all of that. I think that we have to get really radical, but right now in this project, I think there's some really positive things happening. And I don't think the answer is one or the other. And I don't think those two things necessarily have to be against each other. I think that we need lots of solutions now. We need to be flexible. We need to try many different things. That's probably a really wishy-washy, middle of the road answer, but I share your concern. I'm very much from the indigenous kind of side of things, having learned earth building in a country that has no indigenous knowledge. I had to start from scratch and largely learn by looking at the buildings. And when I say no indigenous knowledge, of course, there is some in the southwest of England, but in Scotland, we have very different techniques, very different methods. The buildings look different, feel different, and everybody was dead that built them. So, as I say, learning again. But I'm losing my thread. Roland, what were you keen to say there? I like the way you put your hand up. It was very brave.
I put my hand up to say thanks, Becky. You just pretty well answered everything. Thank you.
Yeah, I don't know.
But I mean, it does sit in the context where certainly in the UK, construction is the most gendered sector. And, you know, that's a symptom of a much wider cultural problem linked to the extractive nature of capitalism and the exploitation that's inherent in the marketplace very often. And, you know, I think potentially CobBauge is a route to subvert the patriarchy in that context. I'm just waiting for comments coming through on the chat on that, because we are running out of time now. There's only a few minutes left. I think Steve's going to give us some final closing remarks in a few minutes, but I wonder, let's just go around the table. And is there any, you know, final pieces of reflection on the CobBauge project from the panel you want to share before we close today? And let's go first down to Matthew and crew down in Plymouth.
We have Kevin here.
It really goes back to a question that Becky raised earlier on, and it was about reusing material again in a different way. And what we found is that it is very flexible, particularly the thermal material, and it's almost by accident that a lot of our thermal mix didn't get used at the end. It might have been not a great amount. It was maybe 2 or 3 wheelbarrows full. But it occurred to me that one way of controlling quality would be to produce a material in its dry form, that you then just gave instructions to how much water you need to add for that. And that linked with conversations we had while we were in America earlier this year. And we've undertaken some tests on retrofitting either wet thermal or dry thermal to existing COB, or in this case, Adobe construction. And over the summer period, we've undertaken some tests on adhesion, both in its wet and dry form. And we were absolutely astonished by the strength of the material bond between the thermal and structural. I think the best we achieved was in a very small sample, something like 30 kilos before the two separated. What we found was that they didn't separate along what you'd imagine to be the fault line between the two materials. They'd split and even split along the structural line, which implied that the part of the structural was so adhered to the thermal that it actually split along the structural line. So I think that prefabrication is definitely another route that we could possibly go down. I've always maintained that this project had a kind of very simple question, was how do you make a traditional building material like cob, modernize it to our own century and improve it, and that not least to meet regulation. But along that road, there's been lots of little side roads that we could have gone down. Mm-hmm. And I think that's a really interesting outcome of the project.
Great, thanks, guys. And for our audience, there is one of the films in our suite of 34 does deal with this issue of bond strength between the two lifts. Anthony, I wonder, you weren't involved in the first phase of CobBauge, which was mostly in the laboratory, and now you're in the thick of it in building your project in Norfolk. Do you have any sort of final reflections on the project and what it's meant to you?
Well, I think as a project and as a research project, it's the biggest one I've been involved in, and I think that it's been amazing because it is an open source thing. We aren't monetizing this. This is for the benefit for anybody who wants to look into it, and I think that's been one of the really, really interesting things. And I think the builders that I've come to talk to about it and the builders that we're working with are also, they feel a responsibility, a moral and ethical responsibility that they've got to look at these kind of construction techniques, and they're actually putting a lot of money into this. They're not. It's much more expensive for them to build this building than a normal building, at the moment. So I think, so they're willing to take that risk, and they realise that we have to push the construction industry in a new direction. And I think this is a fantastic way of doing it. And I was really, really impressed with our, with way Bookie set up that training event also in France, and we had an amazing gender split there. We had probably more than 50% women there, I think, as well. Probably not reflected particularly well on our panel, but it's. I just think it's a really, really positive way to move forward in construction.
I'll hand over to Morgan and Steve, who are going to close this afternoon's session. Maybe just to reaffirm that we will be compositing today's event as an online video, which we will make available, but that may take a week or so for us to share online. But we will send that through to all the people who registered for this event. So thank you for attending. And I hand now over to Steve to close the show.
Good afternoon. My name's Steve Goodhue, and you'll remember me because I introduced the whole of the CobBauge training day. I'm sitting just in front of my own cob summer house, just trying to prove I do believe in earth building myself. I hope you really enjoyed the CobBauge day, and thank you ever so much for sticking with us. There was an awful lot of information. We looked at the science, including a look at the laboratory in the University of Plymouth, and a site visit to Norfolk, where Anthony Hudson's practice, Hudson Architects, showed you around their new build, the first new domestic CobBauge building in the UK. We then had a look at materials, and then building. And we looked at testing, formwork, finishes, and rates of drying. Then we went to a visit for the French site in Carreton, in Normandy, in northern France. Thank you, Francois and Raphael, for that. Then we had a little look at designing of CobBauge buildings, including the role of the architect, alongside the design toolkit, and its in relationship to engineering and detailing. Then you had a visit to the University of Plymouth's CobBauge building. And finally, the chance to discuss and interact with a number of earth building experts about your questions. how does CobBauge work in the real world, how you might use CobBauge as a system to build with. The videos and the documentation, well, they're all available on the website and on our YouTube channel. So I hope you really make full use of all the extra resources that are available. Finally, I'd like to thank all those people that are involved in today's training day. Francois Streiff, Jim Carfrae, Roland Keeble, Anthony Hudson, Becky Little, Barry Haniset, Matt Fox, and above all, Tom Morton. Tom, many, many thanks for the hours that you've put into us and all that work behind the scenes to make sure that everything works really well, and emceeing the event from start to finish. So thank you again, and please have a look at our website,